Okay, we're looking at our test review here. Test will be on Thursday, and so this review here today and tomorrow will prepare you for that. So make sure you make the most of it. I'll run through most of these here and give you some pointers. If triangles are similar, okay, then their sides are proportional. Okay, so sides are proportional. And if we know that they are proportional, then we can write proportions to solve for missing sides. When you write proportions, you take the big side with the big side, the small side with the small side. So 5.5 is bigger than 4.5, and this side that the 11 on looks bigger than the side that the x is on. So I'm going to pair the 5.5 with 11. And I'm going to set that equal to the other two. All right, so I got the small side 4.5 with the small side x. And I just have to be consistent. Okay, go in the same order for each time, and then you can solve for x. Just cross multiply that and solve for x. All right, so when you're writing proportions, make sure you're consistent, and other than that, it'll be pretty good. Okay, to determine if triangles are similar, we have side, 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 we have side, side, and angle, angle. So you're looking at sides here because all I'm given are the sides. All right, so set up proportions, set up ratios for the sides to see if they're all the same. And again, you want to be consistent. So I'm going to put this 5 with this 15, 5 with 15, and then I'm going to go to the next 5, and the next 15, and then I'm going to do the 3 with the 9. So you just want to make sure you're consistent with the corresponding parts going in the same order, and then you simplify each of these fractions. Will reduce down to 1/3. And if they are all the same, then yes, they are similar. Okay, determine if they're similar. Yes, they're similar. Justify your answer. That's which one of these methods you're using. And of course, we're using side, side, side for this one. So say they're similar because of side, side, side. Okay. For number 3, you want to find the x. Notice we've got right angles down here. Okay, whenever you have right angles, you can use Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, so that's what you're going to want to do here. Since we know that this is an isosceles triangle, notice the 12's here. That means that this 10 is going to get cut in half by this vertical, this height here. So I know this piece is going to be 5, and then I can use Pythagorean theorem to solve this for x. Remember, the hypotenuse is always the c. The other two are a and b. It doesn't make a difference which one's which for a and b. So you set it up, solve for x. Number 4 is a good one. You want to solve this for all the missing pieces here, x, p, and r. And so you're going to have to take several steps. But this is a right triangle. It doesn't really give that to you, but there's a right angle right there. So go ahead and put it there. The first thing that I would do is solve for p. Okay, using this smaller triangle on the right, Pythagorean theorem again. Right, we have a right triangle because you'd have a right angle on both sides. The hypotenuse would be the 10, and then there's the a, there's the b. Set that up, solve that for p. Once you've got the p, then you can use the p to find the r, because 15 goes the whole way across there. So if you take off the p, you'd be left with the r. Right, so once you find the p, take 15 minus p, and that will give you the r. And then once you know the r, use the triangle on the left, use this triangle to same thing, Pythagorean theorem, a squared plus b squared equals c squared. Okay, so first find the p, use the p to find the r, then use the r to find the x. All right, number 5, we're looking at another triangle, and we know that this is an isosceles triangle because we have both of these angles are 20. Okay, we're constructing this triangular roof for a shed. How high will the peak be? So the question is, what's this length here? And again, that's going to make a right angle, and it's an isosceles, so it's going to cut that 25 in half. So we're going to have 12.5 for this part of the triangle. And once I know that, well, I have an angle here. Remember SOHCAHTOA, sine, cosine, tangent. Okay, that's what you're using here. So SOHCAHTOA will work here because I know an angle and a side. Okay, I've got an angle and a side. When you've got an angle and a side, SOHCAHTOA will allow you to find any of the other sides. The question is, how high will the peak be? So we're looking for this height here. Okay, that blue line. So if we're looking for the blue line, you think, okay, that's opposite of my angle, and the 12.5 is adjacent to that angle. So what uses opposite and adjacent? Well, that's going to be the tangent, right? TOA. So you set it up, tangent of your angle, tangent of 20 equals opposite, which is the h, over adjacent, which is the 12.5. Then you solve that for h, just multiply the 12.5 on both sides. So you just put that in your calculator, 12.5 times the tangent of 20, and you've got your h. Okay? So that's answering this first question. How high will the peak rise above the roof of the shed? Okay, that's going to answer that question. After the roof is constructed, it will be covered with an asphalt roofing material. The carpenter needs to calculate the combined length of the two sloping sides. So now we want to know how long are these two yellow lines there. So now you're looking for the hypotenuses. Okay, what will the total length be? Okay, so yeah, we just need to find those hypotenuses and add them together. So again, I would use the 12.5, and we want to find this h for hypotenuse now, not for height. I'm going to write the HYP for hypotenuse. So it's the same idea, except now we're using the cosine because we have the adjacent. 12.5 is the adjacent, and we're looking for the hypotenuse. So the cosine equals the adjacent over hypotenuse. Okay, so then once you've got one of them, you've got both of them, just double it or add them together, get the same thing. Okay, number 6 is a straightforward sine, cosine, or tangent. So that one's pretty straightforward, pretty easy. X is the hypotenuse. 10 is adjacent. So again, you're using cosine. All right, so the hypotenuse adjacent, you get the cosine. On to the last page. Okay, number 7 is straight sine, cosine, or tangent, except we're looking for the angle, so that's going to use the inverse. Right? When you're looking for angles, you use the inverse sine, the inverse cosine, or the inverse tangent. So on your calculator, you do second sine, second cosine, second tangent to solve for an angle. Number 8, you're just going to have to do 2 different trig equations, sine, cosine, or tangent. So the right-hand triangle is going to be where you're going to start because you know this 44 here. Okay, we have this angle of 68 and we have the 44, so we can use that to find this green side here. So yeah, use your sine, cosine, tangent to find the green side. And once you got the green side, then you can use that to find the x. Okay. Then number 9 is converting from degrees to radians. We've been doing that a lot lately, but remember pi over 180 will cancel the degrees, so you're multiplying by pi over 180 there. And then number 10, you're asked about the exact value of that. Use that unit circle. You can use the unit circle on the test, so use that to find the exact value there. Remember, the sine is the y value, the cosine is the x value, so it's cosine comma sine, x comma y. And then number 11, remember we have our standard form is a times the sine, or cosine, same thing, of b theta plus c. So a is the amplitude, and 2 pi divided by b will find you your period. The vertical shift is just the c. So the only one you have to do any amount of work for is finding the period with the b value. Okay, work through those. If you have questions, let me know.